some example. This example I took from the textbook only. Preferably, I am giving all the examples from the textbook, prescribed textbook. Okay, if textbook is not having any example, unfortunately, then I'm getting the example from the previous question papers of OU. Now, so this example is what? We do have some n size. N is what? 4 items that you can see here. We were having 4 item profit, 4 item weight. So bag capacity is 8. Now, this 0/1 knapsack problem using dynamic programming can be solved using 2 approaches. One approach is tabulation method. The other approach is sets method. We'll discuss the both as I said in the beginning of this presentation. Now, so I'm taking some table. I'll tell the use of this table also when time comes. Now, here in this table, the way how I'm keeping all the items are, these are what weight. Because when you look at the bag, all 8 kgs of weight we will not keep inside of the bag, right? We'll keep inside of the bag step by step. That will make it happen that 2 kgs are utilized by some object and 3 kgs are utilized by some object. So put together we will be coming for m is equal to 8. So that is the reason why I have divided this figures up to 8. So I'm not going beyond of 8 because my bag capacity is only the 8. So these are what weights. Now this box has to be filled with the profits of the items. Okay. Now, so the way how you have to proceed is, this is your bag. Assume that this is your bag. So in your container, which item you are placing? These are what your items, X size. Now 0 item is placed. When 0 item is placed inside of the bag, obviously the profit is 0 itself. So make it all zeros. Now the next is, you have first object. So I told you in the beginning that dynamic programming will works with optimality of principle. What is optimality of principle? Problem can be solved by taking sequence of decisions. So sequence of decisions means what? Here, when you have only the first object, we will be thinking up to the first object. When you wanted to place the second object, so we will be having 2 objects in our hand. Then when you have third object, we will be getting third also. And the fourth object, we will be going for even fourth. So these are what the sequence of decisions. When you have x1, you will be placing the x1 inside and you will check the profit of it. When you are coming for x2, because bag capacity is not utilized by 1. When you place 1, the weight is what? 2 only. So still 6 kgs of weightage, 6 kg of weight you can utilize. That's what you are going for the second object to place. When you wanted to place second object, you cannot give priority for only second. You have to come for 1 and 2 objects. Now, so after you place second also, if you have any place, any bag capacity is still there to utilize by the other object, now point comes into our mind, the profit. If I place these 2 objects, what is the profit? If I place these 2 objects, what is the profit? So obviously we'll take maximum profit itself, right? So this is optimization problem. It will choose the high profit. Now I wanted to place the first object. When I wanted to place the first object, what is the weight of the object? First object weight, that's what I wrote here. First object weight is 2. So I'll change the ink. First object weight is 2. Now, so these are what weights I told, right? Now, so this is what 2 weight. So here the weight of the first object is 2. That's what I'm making here 1. 1 is not indicates object. 1 indicates profit. Profit of first item. Okay, because I told you that this table will get filled with the profits of the items. Now, sec 2 is the weight of first object. Now I'll get the profit 1 if I place if I utilize 2 weight for the object 1. Now, what values I have to take over here? Whatever values you have in the above, that the values will be come for the next step. So the profit remains same because I have only one object in my hand. Now come to the second object. When it for second object, you have two objects to consider. When you have two objects, these are what the same values because no object is having one weight. So what is the weight of your bag? 8. But weight of your objects are what? 2 and 3. So maximum weight what you will utilize? 3 you will utilize. So come to 3. 3 you are placing 2 because the profit of second object is 2. So it is previous value as it is I am writing. Now, so it at the weight of 4 you cannot place any item, so as it is you are writing. At the place of 5, when the weight is 5 of the container, then you can put these two items together, right? First object and second object you can put over here. That means the profit is 3. 1 plus 2 is 3 and the profit remains the same 3. Okay, so now your bag is having 2 items. Now come to the third step. How many items you have? 1, 2, 3. 3 items you have inside of the bag. Now here a very important thing is when you have these 3 items, what items you have? X1, X2, I'll write here X1, X2, X3 items you have in your hand to place in the container. Now X1 weight is 2, X2 weight is 3, X3 weight is 4. Bag capacity is only 8. If you keep all the items inside of the bag, it goes beyond of the bag capacity. 4 plus 3, 7 plus 2, 9. So it goes beyond of the bag capacity. But we do have a constraint that bag capacity WXI should not be greater than the size of the bag. That's what you cannot place all these 3 items, but you can place any 2 items. If you place 4, 3, X2 and X3, the bag capacity will be utilized only 7. If you place X1 and X3, bag capacity will be 6. So whichever will be give highest profit, that will take. Now look at these 3, which will give highest profit. If I place first item, the profit is only 1. If I place second item, profit is 2. If I place third item, profit is 5. So let's see, second item, third item, the way how we will store. So obviously these values will get 0 because no item is having one weight, so we'll keep the values as 0, the previous values what we have. Now this is also same because when the weight of the bag is 2, we'll place the first object. When the weight of the bag is 3, we'll place the second object. Now come here. When the bag capacity is 4, now what we will be going to do is, now which item you have? X3 item. X3 item is what? 4. Weight of 4. The profit of X3 is what? 5. So write here 5. The weight is 4. X3 item weight is 4. That's what X3 item is getting placed in the table. Now here I am writing only profit. So I write here 5. Now the same value will be writing for 5. And now for 6. 6 is the weight of the bag. Do I have any item to place? Yes, X1 I can place over here. If I place this item, now bag weightage will be what? 4. Already 4 is there. 4 plus 2, 6. Correct? So second item also I am placing. Now 5 plus 1 is 6. The profit is 6. 6. So how much weightage we were used? 4 plus 2, 6 weightage we were used. 6. And now when bag capacity is 7, now what item I am placing? This item I am placing. Okay, which item? X2 item I am placing. When X2 item is getting placed into the 7 cages, in the weight of 7, now what is the profit? Already 4 is utilized. So 5 plus 2, 7. 5 plus 2 is 7, so 7. Right? Now, x4. x4, 0, 0. Already 1 placed and your 1, 2 items placed. And your even x3 also placed. And now, for 5 weightage, already we do have which item? This 4 item, right? 4 item is what? Profit is 6. And the weightage is 5. So wherever it is 5, there I am writing profit is 6. Now 6, 7, 8. Now what we were done is, according to the sequence of decisions, we were placed inside of the bag. Now you have to check for which values the bag capacity and the profit constraints will get satisfied. So we will be doing even using of the formula. The formula we were seen in the before slide, right? The formula is this. The formula is this. So how to calculate the this values, the table values? We were given values as far as table is considered, but we do have a formula to find out the values in the table. The formula is, let fj of y be the value of an optimal solution to a knapsack. Since the principle of optimality holds, we obtain fn of m is equal to max of fn minus 1 of m, comma, fn minus 1 of m minus wn plus pn. We'll use this formula to calculate at least one cell of the value so that you will be having confident to move forward, right? Now we will take that value. We'll calculate for 1. Now we'll take this, we'll take the last row values, whatever values we got. The last row values I'm taking, because I'm going to calculate using of the formula the values what we were just now got from the previous example. These are what the last column, a last row. If I place 4th item, these are the values. Now apply the formula to check the same. Now the formula is vi comma w is equal to max of vi minus 1 comma w comma vi minus 1 comma w minus wi plus p of I. This is the formula. Now I is what? The item what you wanted to place. So item is what? 4. Now 4. W is what? The weight. The weight. Now I am taking weight which is 4 comma 1. Now max is max of v of I minus 1. That is, it is I is 4. I minus 1 is 3 comma w weight is what? 1 comma v of 3 comma, because it is I minus 1 again. Now w minus wi 1 minus 5. This 5 is what? wi. I value is 4. Weight of this 4. Weight of the 4 is what? In the problem we were taken, right? So what is the value? P is equal to 1 comma 2 5 6. W is equal to 2 3 4 5. Now the last item, the 4th item weight is what? 5. Now that's what I wrote here, 5. 5 plus PI, that is profit of the last item, which is 6. Now calculate V of 3 comma 1. In the table, V of 3 comma 1 is 0. 0 comma V of 3 comma minus 4 plus 6. Now this value is what? Undefined, because we did not have a negative index, right? We do have 3 comma 4 index from the table, but we don't have 3 comma minus 4. So it is undefined. That means we will take the value as 0. So for 4 comma 1 value is 0. Now these are what the indexes. So 4 comma 1 value is 0. Now, so you can take the same way to get all the values. So now we will see even the other value. V of 4 comma 5 is equal to max V of 3 comma 5 comma V of 3 comma 5 minus 5 plus 6. That is max of 5 comma 0 plus 6. From where I got the 0? 3 comma 1. The value of 3 comma 1 from the table, it is 0. So which value is maximum? Maximum value in between 5 comma 6 is 6. So we'll update the value of 6 in the place of 4 comma 5 in the table. In the same way, you can calculate 4 comma 6. You'll get max of V3 comma 6 comma V3 comma 6 minus 5 plus 6. Max of, from the table, V3 comma 6 value is 6. From the table, V3 comma 1 value is 0 and plus 6. Max is 6. So you can find the same values in the table. Though you apply table values, though you apply this formula, you will get the same values. Right? Now, so what we were done so far, we were taken sequence of decisions to see which item can be placed in the bag. So that was we were done so far, right? Now the thing is, we do have x1, x2, x3, x4. Now in the last table, the last row of the table is maximum profit. We found at it is 8. That means what? If it is a maximum profit of the entire this problem, then who will give this maximum profit? When we got this maximum profit, in the 4th row you got this maximum profit. Not in the 1, not in the 2, not in the 3. That means maximum profit is not from placing first object, second object, third object, but in the placing of 4th object. That means for sure you should place x4 to get maximum profit. So x4 item has to be inside of your container. So when you place x4 item, actual capacity of your bag is what? 8 minus. What is the weight of this bag? What is the weight of this item? 6. 8 minus 6 is 2. Okay. The 6 is what? Profit of x4. So leftover weight is what? 2. That means still this weight you can utilize. Now, so which value giving this 2? That you can check from the table. That the weight of x2 is what from the example? That we will be placing x2 item. So x1, x2, x3, x4. x4 is placed, x3 is not placed, x2 is placed, and this. Now what is the profit of x2? Profit of x2 is 2. Profit of x4 is 6. That means we got 6 plus 2 is 8. Now bag capacity is x2 capacity is 3, x4 capacity is 5, bag capacity is 8. So finally, which items we were placed inside of the container? x2 and x4. So this is from the tabulation method. So now we'll